Today we're going to go over inverse functions, and in my notebook I went ahead and made a new page. Mine is page 9. Yours may be a little different. So again, we're going over inverse functions. So it's important to know when we're talking about inverse functions, we're usually, these are the words that we're going to be using. So when we have a function, the inverse of that function is usually the opposite, the reverse, or you can say it goes the other way. So these are just different ways that we can describe an inverse. So let's go ahead and find out how to actually find the inverse itself. So first is algebraically. So these are 4 steps that we're going to do to find an inverse algebraically. So let's go ahead and start. The first step is going to be, you're going to change the f of x to y. The second step is you're going to actually be switching your x's and your y's. Then you're going to solve for y. And last, you're going to change the notation to the inverse notation. So you're going to change it to f negative 1 of x. So that's the inverse notation. So let's go ahead and try an example. And I wrote down the steps here just in case you need to see them. Okay, so the first step, I'm going to change my f of x to a y. So I'm going to write y equals 3x plus 2. Okay, so I did the first step. My second step, switch my x's and my y's. So my y's become x's and my x's become y's. Okay, my third step is to solve for y. So I know that we've been doing that, so I know that you guys are pros at this. So I'm going to subtract 2 and this will give me 0. My 3 drops down, so it's 3y. And on this side, I have no like terms, so I'm just going to rewrite them. My last step is to divide by 3. So I'm going to divide each term by 3. Okay, so 3 divided by 3 is 1, so that'll leave me with y. And on the other side, I have nothing that simplifies, so I'm just going to rewrite it so that it looks a little nicer. Okay, so if I look at my steps, I've already solved for y. My last step is to change y to f inverse. So I'm going to go ahead and write my f inverse equals x minus 2. My function stays the same. Okay, so that is finished. Okay, let's try another example. So for this one, I have f of x equals 7x squared minus 14. So again, my first step, change my f of x to y. So y equals, that's the only thing I'm changing. Everything else stays the same. My second step is to switch my x's and my y's. So my y's become x's and my x's become y's. Everything else stays the same. My third step is to solve for y. So I'm going to move this 14 over. This becomes 0. I drop down my 7y squared. So I have 7y squared equals, and nothing over here simplifies, so I just rewrite. Okay, so now I divide by my 7. So I divide each term. If I do it to one side, I have to do it to the other. So 1 divided by 1 will give me y squared. And over here, I can simplify this, x over 7. And 14 divided by 7 is 2. Okay. So as you can see, I still have one more thing to do. I have to get rid of this squared term. So if you haven't figured it out already, whenever we move something to the other side of the equal sign, we're doing the opposite operation. So if we look up here, remember the opposite, so we're actually doing the inverse. So it's important to know that the inverse of a squared is a square root. So inverse of x squared is a square root. Okay, so I'm going to take the square root of y squared and the square root of this side. So my square root and my square cancel, and I'm just gonna be left with y. And on this side, nothing else changes. Plus 2, that stays the same. So if I look at my steps, my last step is to change my y to f inverse. So that's what I'm going to do. I'm gonna write f inverse of x is equal to, now for the square root, you have to consider both the positive and the negative, and we'll see that next week. But we're gonna put a plus and a minus because we're considering both the positive and the negative of x over 7 plus 2. So that is the inverse algebraically.